it is known that the height h in meters of trees of a certain kind has a normal distribution with a mean of 12.5 and a variance of 10.24. So for this case here, h here is the height of trees. It follows a normal distribution with a mean of 12.5 and a variance of 10.24. A scientist takes a random sample of 25 trees. So n is 25 here, and finds the sample mean h bar. We need to state the distribution of the sample mean. If n is 25, then the distribution of sample mean is also a normal distribution. It takes the same mean value as the distribution of h, which is 12.5. The variance now. The variance of h bar is actually the variance of h divided by n, which is the sample size, which is 25. So the variance of h is 10.24 divided by 25, and we get a value of 0.4096. So h bar follows a normal distribution with a mean of 12.5 and a variance of 0.4096. Part B, we need to find the probability that h bar is between 12 and 13. So we have the distribution of h bar, and we are going to use this to find the probability that h bar is in between 12 and 13. First, we standardize. We take all these values, subtract the mean, which is 12.5, and divide by the standard deviation. 0.4096 is a variance. The standard deviation is the square root of the variance, and h bar becomes exact now. We have 13 minus 12.5 over square root of 0.4096. Z now follows the standard normal distribution. And this value is negative 0.781. So Z now is in between negative 0.781 and 0.781. We need to find this probability now. Let's look at this. If Z is in between negative 0.781, this is negative 0.781, and we have 0.781. We need to find this area. Okay, in order to find this area, the standard normal table given to you is just a left tail table. This is 0.781. We have this value here. We need to subtract this now. Yeah, they don't look that perfect, so. Okay, we take this value and we subtract by this to get what we have here. This is what we need to do. So this value we can get directly from the standard normal table, and this is 0.7826. We need to subtract this value. That if this is 0.7826 from symmetry, we know that this and that unshaded region are exactly the same. This area is 1 minus 0.7826. So to find the required probability, we have 0.7826 minus this small little area here. So we subtract 1 minus 0.7826. And we get 0.5652. That is 0.565 to 3 significant.